Welcome to Scholar Sauce. This is our fourth and final video in a series about factoring trinomials. And what we're going to talk about in this video is how factoring trinomials fits into the greater world of mathematics. Now, when you're asked to factor trinomials as a student, it's not actually because when you get a job somewhere, you're going to factor trinomials. In fact, most of you, after you take a class in algebra, will likely never factor a trinomial by hand ever again. And that's okay, because that's actually not the purpose of the exercise. The real reason why you need to learn how to factor trinomials and why it's included in algebra classes is because it helps us understand the behavior of polynomials a little bit. For example, if you have a polynomial like p of x, and it has a factor x minus r, then x equals r is a root. So being able to factor a trinomial or any other kind of polynomial tells you where its roots are. Now the roots are the zeros of the function. Finding zeros of a polynomial has a whole bunch of different applications as soon as you realize that polynomials themselves have a bunch of applications. In fact, you can identify the entire behavior of a polynomial by looking at its zeros and the zeros of its successive derivatives, all of which are also polynomials. Well, where do polynomials come into play? Practically every single quantity in nature has some functional relationship with other quantities that it depends on or that depend on it. And we can find models for these relationships all over the place. And it turns out a lot of them are actually polynomial relationships. For example, free fall as a function of time, your motion under gravity, is a polynomial relationship in time. Also in economics, most profit, cost, and revenue models are polynomial functions. And also in statistical analysis, quite often you'll look for a polynomial model to model some data that you have. Power laws, which are a type of polynomial, can be used to model all sorts of things in nature, particularly astronomical things, or things in which they behave the same no matter how you scale them. It relates to other kind of ideas too, because we can detect when a power model is the right model by using something called a log-log plot, which is pretty neat. What this does is if you have two variables, say y and x is the independent variable, y is the dependent, and they're related by some kind of power function, say y equals k x to the n, then when you take the logarithm of both sides and do some of the properties of logarithms, you can find out that the logarithm of y and the logarithm of x are actually related linearly. So instead of plotting the initial data, what you could do is you could plot the logarithms of both your independent variable data and your dependent variable data and plot it and see if it's linear. If it is, the original function was a power function, and you can go back and find that model very easily by using that linear regression stuff. And this one's pretty cool. For most common differentiable functions like exponential, logarithmic, trigonometric, and rational functions, it turns out that in the small, that when you restrict your domain to a tiny little bit, you can always approximate that function really well, in fact, as well as you want, using a polynomial. And so polynomials can be used in small ranges to actually model pretty much every single relationship. So knowing how they behave is fundamental to helping us understand the world around us. And that's why we start with polynomials in algebra, is because they end up being the foundation of a whole bunch of other things. And beyond that, the fact that they're actually pretty easy to understand and pretty easy to use makes them really great examples of other kinds of ideas that are really important. For example, the derivative in calculus talks about rates of change and how fast functions change with relation to each other. If you want to understand that concept and do calculations with that, you need some toy problems to work on. And polynomials provide a ton of different toy problems that you can do in order to understand how derivatives are producing rates of change and stuff like that, so that you can prepare to use derivatives in more complicated settings. But if you're not going on to calculus, you're not going to study science, you're not going to go in the other places, why does studying polynomials help? What does it do for you? Well, this is the other part about mathematics in general and why it's important to learn math. When you study polynomials and things like factoring trinomials or other kinds of things like that, you're exercising your brain in order to think about things critically and understand how certain things work. Just like when a professional sports player exercises, they might do some exercises that aren't related to actually what they do in the court. For example, like weightlifting, it's not really clear how those weightlifting exercises translate exactly into basketball or something like that, but they do, because they exercise certain muscles and muscle groups that you'll use when you play. Mathematics is the same kind of way. When we do things like factoring trinomials or stuff like that for people who might not use them later, you're exercising parts of your brain and exercising how it thinks and practicing and making your brain stronger and being able to understand bigger ideas that are more complicated and ideas that you might be more interested in. And so it even helps people who may not ever touch a polynomial again after algebra. In fact, all of mathematics, even if you end up not doing anything else with it, helps you with that kind of idea. It's all about exercising. That's actually why we call homework problems exercises, because you're practicing, you're challenging yourself, you're growing your brain and becoming smarter and understanding the world around you even more. So there's tons of really great content that you can understand when you look at polynomials. Well, thanks for watching this last episode in our series on factoring trinomials. If you found it interesting, I hope that you'll stick around and watch a few of our other content on Scholar Sauce. We don't just do homework help videos. We also do some fun math content where you can see how math behaves in the real world, or just some neat, beautiful things that are in mathematics. And you can check out examples of those videos here. If you enjoyed this video, please like and subscribe to Scholar Sauce, and we'll see you next time.